Hello everyone. In today's video, we are talking about domain and range. So first of all, let's talk about domain. It is known as all the possible x values based off of the graph. And remember, x values go from left to right. Next up, we take a look at range. And range is all the possible y values for the graph. And again, for the y values, we go from down to up. And we normally use set notation, and this is the type of notation you guys will be using from grades 8 to 12. So let's take a look at some examples. So the first one here is probably one of the most common ones you will see, where D for domain is given by XER, where this E is kind of like a rounded capital E, and the R is a capital R with a line behind it. So we read it as X is an element, so that's what the rounded E stands for, element of the set of all real numbers. And that is what the capital R with a line behind it is. That means set of all real numbers. That is the notation that we use. You might also see ones where it's like domain is given by x is less than 1. And you're probably used to seeing these as these are just your typical inequalities. So that means it can't be 1, but you start from 1 and you go to the left, but you cannot include 1. You might also get ranges, or domains can also be written like this. Remember, domain is always with X material, range is always with Y material. So you might have Y is greater than or equal to 1, written like this. You might as well have something like where it's like -5 less than or equal to Y less than 2, where Y is being sandwiched between a minimum and a maximum value. So again, we can read that as Y is between -5 and 2, but not equal to 2. So again, you see that there's -5 less than equal, but then the 2, there's no equal line there. So let's take a look at some examples here. So for example, we have the following. Find the domain and range of each one, and we're going to be doing this in set notation. So first of all, the first one here, if we want domain, that means we're looking from left to right. And we see here that this arrow kind of tells us that this can keep going forever. So arrows tell us that they keep going on forever. And this means it gets wider and wider and wider to the left side. This arrow here, oops, let's do this. This arrow here tells us that we keep going on forever and it will keep going to the right side. So also, we can see here that in between, we are combining these values here. So you can see from left to right, everything would technically be connected. So we conclude with x, e, r, telling us that x can be whatever it wants from -infinity all the way to +infinity. Now let's take a look at the range values. The range values is fixed based off of this point here. That is our lowest point, right? And now we'll look at 0, -4. So that means -4, which is the y value, is the lowest value possible. And we see here that since our arrows go upwards and outwards, that they can keep rising however they want. So our range tells us that we can go infinitely high, like this. So it just keeps going upwards from -4. So we write that as an inequality of y is greater than or equal to -4. Let's take a look at example number 2. We see here that we have a starting point on the left side that's given by -4, -2. So this is our most left point, right? There's no arrows in this case telling us that this is kind of like a stopping point or a starting point. And we can see here that this arrow here tells us that our line can keep going all the way to the right from that point onwards. So from the starting point of -4, we can go all the way right without any issues like this. So this tells us that we need to write an inequality where it's x is greater than or equal to -4. And you did notice here that we started with a solid point, like it was colored in. If it's colored in, that means you can have equal sign. If it's an open circle, this tells us that we cannot have equal signs underneath. So normally it would be a circle without it being colored in. So an open circle means no equal sign. So I'll write that there, open circle, no equal sign. And then for the range, again, the starting point is our lowest point, where the y value is -2, and we see that the arrow goes to the right and upwards, so it keeps going up, 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 up. So that means our values just keep going upwards. Sorry. This keep going upwards, so we have that y is greater than or equal to -2. Now let's talk about one last example where we don't have straight lines. For example, this one here. These ones here, we have points that are kind of separated apart from each other. These ones here are known as discrete points. Discrete basically means that these are separated points. So let's take a look at the coordinates of each of these ones here. So this one here is given by 0, 0. So we'll go from left to right, 0, 0. The next one here is given by 1, comma, 1, 2, 3, 4, 5. And the next one here would be 2, comma, 1. And the last one here is 3, comma, 4. So those are each of the individual points. Now, whenever you have them as separate points, we cannot write an inequality because they're not connected. So the way we represent it is we do a squiggly line like this. This tells us that we're going to start listing values now. So the x values, right, is going to be 0, 1, 2, and 3. And then we go close squiggly line to show that this is the set of numbers that x can be. So remember, in coordinate form, it's always x comma y, right? It's always in alphabetical order. And lastly, the range here, let's take a look at the y values. We have 0. We want to go from smallest to biggest. So in this case, we would go 0, then 1, then 4, then 5, from smallest to biggest. So 1, 4, and 5. Now, the reason why we have discrete points is because maybe the item or unit that we're talking about cannot be connected with a line. Normally, if you can connect with a line, that means you can have fractions and decimals of that unit. So in this situation, maybe your units are cookies or people, for example. If you cannot connect the line, that means no fraction. So you can't have 1/12 of a cookie, or you can't have 1/12 of a human, right? Those are normally in whole numbers. So this is why we have discrete points as well. So that does it for today's video. I hope you guys learned something and it helped clarify some of the misunderstandings. Please make sure to like the video and also share and subscribe to the channel if you like this content. Feel free to leave a comment below how you felt about it and give me any feedback if possible. Thank you so much for watching, and I'll see you guys in the next one.